Well, Chapter 2 in Hibbler deals with force vectors, and we're going to start out with section 2.1 and 2.2, which deals with scalar and vector operations. So, when we talk about a scalar, we're talking about a quantity with only a magnitude. For example, time. Like 31 seconds, just a magnitude. Speed is another scalar, maybe 24 miles per hour. So, only a magnitude. On the other hand, a vector has a magnitude and a direction. So the vector here in blue might have a direction from some reference here of 45 degrees, and then again the vector is the blue arrow, might have a force of 10 newtons, magnitude and direction. So let's talk about some vector operations. More specifically, some coplanar. These are operations in the same plane of vectors. So we can take a vector, say here, we might label this as vector A, and in a book it's probably bolded, bold letters, so you can distinguish it from a non-vector, which was not bolded. But in our case, we will just put a little symbol over the top of it. Now we can take that vector labeled A and we can add it to another vector. Let's make it an orange vector. We'll call it vector B. So A, oops, didn't register. A plus B will result in a new vector. We'll call vector C, or maybe vector R better, as the resultant vector. So we can add this in one of two ways. We can take this vector and start with A, and then to it add B, and vector R that results will then start where the first vector started, in this case A, and end where the second vector ended, and that is our vector R. So A plus B equals R. We could reverse the process and start with B, and we'll get the same thing. So we could go vector B plus vector A equals vector R. Notice it's exactly the same. Same size, same direction, same magnitude I should say, same direction, same everything. So that was addition. We can also do vector subtraction in much the same way. say we start with A and B, well, A minus B is really the same thing as A plus, so we're adding the vector still, but we're adding a negative B vector this time. So this equals then A in this direction, but now B is pointed backwards, is negative. So the resultant then is putting the two together this way. So again, this is minus B, put it in parentheses, A, so that results in A minus B equals our resultant vector. We can perform we can perform operations on multiple vectors. So let's see, we have that one. Then we're going to add to that this one, and then we're going to add to that this one, and I guess we'll stop there. But you can see that this is our first resultant, and our final resultant, so this would be like one vector plus this vector. Our final resultant then is just like this. So we might have A, B, and C. Okay, so let's look at vector addition of a coplanar concurrent force. So everything acting at the same point is what concurrent means. Let's say we have vector P vector Q and vector S here. So this is what we're given, and we want to find resultant. And for our solution, we'll take and add these all together. Then in orange, our resultant will be here, like that. So we could replace all three of these forces by just this one resultant, and they would have the same effect on that particle. Sometimes we desire to do the opposite of finding the resultant. We have the resultant, or some force, and we want to resolve it into components. Well, we have to decide how. A lot of times we will resolve this into the mutually perpendicular components, something like that. So we'll figure out what the components are to this force, in the x and the y direction. Let's extend this, because this will be the x component, obviously, and this length will be the y component. But many times we're going to try to come up with components for a force when for just two general directions. For example, so suppose we want to resolve the force into two components in the direction of the purple lines. They're not perpendicular necessarily. Well, what we could do is we could create the this situation. So this is exactly, runs in the direction of that, and we need to make sure that we cross the tip and touch the other line with a line that's parallel to this bottom line, so this green line up here. So in essence what we do is then we have two vectors. We have this one as one component, then we have this one as the second component heading in this direction. Let's do an example here. Okay, so we have two members connected by a pin here attached to the walls, and there's a 600-pound force on them. So let's find the components of that force along those members. So find the components of the 600-pound force along the members. So we have the 600 pound. Let us start here. And I'm going to do this the opposite direction that the so we can think of this as opposite. I'm going to do opposite of your book. We can think of this as a vector heading in this direction, and then a vector heading in this direction. Okay. Let us make that bigger. We'll blow it up proportionally so we can study it a little. So in essence, this is our first vector, and then this is our second vector. It gives us a resultant of 600. Okay, let's fill in some angles. We know that this angle here to this is 30 degrees. That makes this angle 30 degrees. And if this angle is 30 degrees, this angle has to be enough to make this equal to 180 degrees. But hold on a second. This line is actually this line cutting down here. So think of this cutting like this. This is 60 minus 180, or 120 degrees. So we know that since this here is 60 degrees, that this angle must be 120 degrees. And we could fill this one in too. 150 and 30, and this is 30 degrees here too. And we could find this other in multiple ways.